My name is Daniela Katos. I'm responsible for new rear lamp technologies in the innovations department at HELLA. And today I'd like to give you a short introduction in 6 minutes, really not a lot of time, but we will make that, about freeform optics in automotive applications. So let's start with a short introduction to HELLA. So we have a long history in automotive industry. We are founded in 1899, and today we are one of the leading suppliers here. We have many locations in more than 35 countries, and we have more than 36,000 employees worldwide, with about 8,000 in research and development. And our portfolio is separated in 3 different segments. We have automotive, aftermarket, and special applications. Today, we will focus on automotive, and here you see some products that are developed by HELLA, headlamps, rear lamps, I think the classical components for automotive lighting systems. We have also car body lighting and interior lighting, and lighting electronics and radomes. So take the question first, what we can provide if we collaborate with you together. Of course, regarding our history, we have a lot of experience in automotive systems, and especially, of course, in automotive lighting systems. We have a large industry and research network, and of course, access to a worldwide automotive market. As shown in the slide before, we have a wide range of applications in interior and exterior lighting. And of course, we need different optical solutions for these different applications. So we are open for development, common development with you for new innovative lighting systems, for new innovative optical systems. So let's start with the topic of today, freeform optics in automotive applications. So first, point at the beginning, freeform optics is nothing new for automotive lighting, of course. So we use them since many years, for example, as tier optics, as you can see in the image here. We use them for imaging optics in headlamps, and also as in and out coupling optics for light guides for signal and rear lamps. All these optical components have in common that they are, let's say, macro sized. So this means they have a size of about 1 millimeter, sometimes larger, sometimes a little bit below. And the advantage is, of course, that we can manufacture with injection molding processes, and this is a standard in automotive industry. But the disadvantage is that, the size of the components itself is a little bit larger. And on the other hand, of course, the size of the optical structure is clearly visible very often. And this is especially a point that we want to avoid from styling reasons. So especially in off-state appearance, we want to hide this structure. And this is also the reason why we look for new developments. And one of this is the freeform micro-optics. So we see the advantages in the increase of efficiency. We also think that we can reduce the installation space and weight, which is of course important when we look for electrification, for example. And as I mentioned, the new styling options that we have with this micro-optics. So one of the projects we are involved is already mentioned. So we have here the PHABULOuS project. We are one of the use case partners, and we look for double-sided freeform micro-optics for a headlamp application. This means that we want to generate an optical system that is really slim. As you can see by the image of the headlamp, we want to realize a really slim light out coupling surface, and we want to generate, for example, a low beam distribution, a typical illumination distribution on the street, as shown in the image below. Another current development is for rear lamps. This is a so-called HELLA Flatlight Micro MX. You might already know it from a press release in January. So maybe a first introduction to flatlight. So flatlight is for us a technology range. And these technologies enable us to generate a really homogeneous luminous surface combined with a thin package, as you can see by the images here. And the Micro MX technology is something special because we use an optical stack here, and we have different optical layers. And the layers are double-sided or one-sided, and also with freeform micro-optics on it. And the stack together enable us to have this really nice appearance, and we can use it with several wavelengths, so that we have on the one hand the wonderful appearance as mentioned, but also the possibility to have different functionalities, for example, stop or turn indicator or something like that. So what we demand and what is really important for us is that we have to look for the automotive conditions that we are faced with. So you can see here by this image several requirements we have, especially for the materials that are to be used. We have a wide range of temperature that we have in the automotive area. You see that the material is, for example, exposed by UV and sunlight. It gets in contact with water, with gas, and also with cleaning liquids. So a lot of requirements here regarding the materials. We have to avoid deformation. We have to avoid delamination, especially when we use material bonds. And of course, we need to avoid yellowing or turbidity. And with this, I come to the points where you can help us. So for example, we need to use always automotive certified materials. So if you have really specific materials in your portfolio that are withstand all these conditions that we have in the automotive industry, that would be really interesting for us. We need to realize the freeform micro or freeform optics in general, but with focus on micro optics, of course. We need to have them on curved substrates, 3D curved substrates, because our products often have to follow the vehicle curvature of the car. Yeah, and on the other hand, of course, we need to find a technology that is cost effective regarding mastering and also the series production. And this was a really rough overview about automotive applications. And yeah, I'm really happy to answer your questions right now.